Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P2646, indicates that the VTEC, Variable Valve Timing and Lift Electronic Control system, is experiencing an issue, specifically that it is stuck in the off position. The VTEC system is crucial for optimizing engine performance by adjusting the timing and lift of the engine's valves, depending on engine speed and load. It employs a rocker arm oil pressure sensor, known as the EOP sensor, located typically on the cylinder head to monitor oil pressure that activates the system. A malfunction can affect engine efficiency, power output, and emissions. When the system remains in the off position, the engine may not perform effectively, leading to reduced power and possible further engine complications. Addressing this issue promptly is essential for maintaining optimal engine performance and longevity. The VTEC system's primary role is to enhance engine efficiency and performance by providing variable timing and lift to valves. At the heart of the VTEC system is the rocker arm oil pressure sensor, or EOP sensor, which monitors the oil pressure necessary for VTEC operation. This sensor is located on the engine's cylinder head. If the sensor detects inadequate oil pressure, it triggers the DTC P2646, indicating that the VTEC system is unable to switch on when required. The engine operates under predefined conditions, and when the sensor fails to provide the required pressure, it reflects a potential issue with the oil controls or pressure within the system. Therefore, understanding the role of the EOP sensor is crucial for troubleshooting the DTC P2646 effectively. There are several possible causes for the DTC P2646 to trigger. First and foremost is the engine oil level. If it's too low, the EOP sensor may not function effectively, leading the system to remain in the off state. Secondly, a faulty EOP sensor can misleadingly report pressure levels, preventing the VTEC from engaging. Additionally, a malfunctioning rocker arm oil control valve can prevent proper oil flow within the system, causing similar issues. Each of these components plays a role in managing oil pressure, crucial for VTEC functionality. Thus, identifying the exact cause requires thorough inspection of oil levels and functionality of the relevant sensors and valves. When the DTC P2646 is active, drivers may experience several symptoms indicative of VTEC system issues. One of the most noticeable symptoms is a reduction in engine performance, which can manifest as sluggish acceleration or poor responsiveness when attempting to speed up. This happens because the VTEC system fails to engage, causing the engine to run less efficiently. Furthermore, the check engine light, CEL, will illuminate on the dashboard, indicating that there's a fault that needs addressing. Other potential symptoms could include increased fuel consumption due to a lack of optimal engine performance, and drivers might find that the engine does not rev as freely as it should. These symptoms collectively signal that addressing the DTC P2646 is crucial for restoring proper engine functionality. The first step in troubleshooting DTC P2646 is to check the engine oil level. This is essential because the oil level directly impacts the VTEC operation, with low levels potentially leading to inadequate oil pressure and subsequent faults. Use the dipstick to verify that the oil is at the recommended level. If the oil level is adequate, proceed to the next troubleshooting step. Conversely, if you discover that the oil level is low, it is necessary to add the appropriate engine oil to bring it to the correct level before continuing. Maintaining a proper oil level not only ensures VTEC function, but also protects the engine from damage due to lack of lubrication. Next, you will want to turn the ignition switch to the on position without starting the engine. This allows you to prepare for further diagnostics. It is important to ensure the dashboard lights illuminate, indicating the electrical systems are operational. This step paves the way for the subsequent action of clearing the DTC using Honda's Diagnostic System, HDS. Clearing the code is essential for performing further tests to check whether the issue is persistent or intermittent. Once the ignition is in the on position, confirm that the HDS is ready to access the diagnostic menu for the next troubleshooting phase. In this step, you will clear the DTC using the Honda Diagnostic System, HDS. The HDS is a specialized tool used for diagnosing various issues within Honda vehicles. By clearing the DTC, you reset any existing error codes in the system. This action may help determine if the fault is temporary or if it reoccurs, allowing for a more thorough assessment of the VTEC system functionality. Remember, this step should be executed with precision, ensuring that all other necessary data is recorded beforehand for a complete diagnostic picture. After clearing the code, it's crucial to conduct tests to confirm whether the VTEC system operates correctly moving forward. With the DTC cleared, the next step involves performing a VTEC test using the HDS. This test is critical as it allows you to assess the functionality of the VTEC system in real time, verifying whether it is engaging correctly under operational conditions. Carefully monitor the diagnostic results presented by the HDS post-test. If the results indicate that the system operates correctly, it is likely an intermittent failure. However, if the test returns an error, further investigation is warranted. During this step, also check for any poor connections or loose terminals that could hinder normal operation. Identifying and rectifying these common issues may resolve the DTC P2646 without needing further parts replacement. For the fifth troubleshooting step, turn the ignition switch to the lock 0 position. This is a critical step as it ensures all electrical systems are powered down safely before proceeding with hardware inspections. It is essential to do this before removing any components so as to avoid potential electrical shorts or further issues. Once the ignition is off, you can safely assess the physical components involved in the VTEC operation, such as the rocker arm oil pressure sensor. Ensuring that the systems are powered down prior to inspection increases safety and helps maintain system integrity as you move forward in troubleshooting the P2646 error. The sixth step involves physically accessing and removing the rocker arm oil pressure sensor, also known as the EOP sensor. Ensure you handle this component carefully, as it is sensitive and can be easily damaged. After removal, your next task is to attach the specified special tools needed for the oil pressure diagnosis, such as the pressure gauge adapter and oil pressure gauge. Align them correctly according to the manufacturer's guidelines to ensure an accurate assessment. Installing these tools properly is critical for obtaining reliable readings for oil pressure, which directly influences the VTEC system's functionality. Remember to keep the new O-ring handy for reinstallation to prevent oil leaks once you're finished. After successfully attaching all special tools, start the engine and hold the RPM at 3000 without load. This is crucial because it allows the VTEC system to reach operational parameters and facilitates the oil pressure testing while eliminating any additional loads that may skew results. Doing so enables the radiator fan to activate, which is part of the operational checklist for the engine. After maintaining this engine speed, let the engine idle for 2 minutes to ensure the oil circulates properly through the system and stabilizes under typical operating conditions. This sequence enhances the accuracy of the subsequent VTEC test and oil pressure assessment. ensuring that any readings obtained will be representative of the system's performance. With the engine running and warmed up, you'll need to conduct the VTEC test once again using the HDS. By running the test at this stage, you can ascertain real-time data reflecting the current operating conditions of the VTEC system. Collect and record all output from the diagnostic tool methodically. This will indicate whether the system engages properly now that the engine is properly warmed and oil is circulating effectively. It's important to compare these results to those obtained in prior tests to determine if repairs or adjustments were successful. This step is critical as it either confirms the effectiveness of previous troubleshooting steps or indicates further investigation is needed. The final step in the troubleshooting process is to check the oil pressure readings obtained from the HDS. Specifically, you will want to monitor whether the oil pressure increases to the expected level of 392 kilopascals, or approximately 56.9 psi. Achieving this specified pressure is essential for the VTEC system to operate effectively. If the oil pressure meets or exceeds this threshold, it indicates that the rocker arm oil pressure sensor is likely faulty and should be replaced. Conversely, if the pressure does not meet the specified level, this could indicate issues such as a blockage in the VTEC system oil line, necessitating further inspection and potential replacement of the rocker arm oil control valve. Accurately diagnosing the oil pressure will guide the next repair steps. After completing the troubleshooting steps and making necessary repairs, it is crucial to perform a final verification of the work done. This includes replacing any identified faulty components, such as the rocker arm oil pressure sensor, and ensuring that all connections are secure and free of corrosion. Once replacements are complete, conducting another VTEC test via the HDS allows you to confirm that the system operates as intended, engaging and disengaging appropriately under varying conditions. Validating the successful repairs ensures no residual DTC exists and that the engine is running optimally. This final step solidifies the integrity of the repairs and reinforces the proper function of the VTEC system. Preventive maintenance is paramount in avoiding future occurrences of DTC P2646. Implementing regular oil changes according to manufacturer recommendations is essential, as these ensure the engine is always lubricated with clean, effective oil. Additionally, routinely checking and topping off the engine oil level can prevent low oil situations that might lead to poor VTEC system performance. It's important to maintain an awareness of oil quality as well, as degraded oil can affect lubrication and pressure. By adhering to these maintenance practices, you can enhance the longevity of the VTEC system and the overall health of the engine, reducing the risk of recurring issues and costly repairs. In conclusion, the DTC P2646 code indicates a serious issue with the VTEC system, specifically signaling that it is stuck in the off position. The troubleshooting steps outlined provide a structured approach to diagnose and rectify the issue effectively. Regular maintenance, such as checking oil levels and ensuring good oil quality, can prevent these problems from surfacing. Understanding the role of components like the EOP sensor and rocker arm oil control valve is vital to a successful repair. By adhering to proper diagnosis and maintenance strategies, vehicle owners can ensure that their Honda Civics VTEC system remains functional and efficient, preserving both the performance and longevity of their engine. Proactive measures pay dividends in reducing repair costs and improving the overall driving experience. Please like and subscribe to the channel. See you next time.